Hello students, this is the second model in the evaluation of options and the important one, that is Black Scholes Model. Okay, you read the problem clearly which is given in the slide, and we are supposed to calculate the values of call and put options using Black Scholes Model, and current price is given, excess price times to time to expiry, everything is given. Okay, so we all know the formula. Okay, let me write it for you so that so the call option formula is given as S naught n of d1 minus e power minus rt into n of d2. Okay, in this E is the exercise price, S naught is the current stock price, and d1 is the value of the cumulative normal distribution, and R is the interest rate, and T is the time, as we are aware, and we have to calculate d1 and d2 and apply in this formula. And we also have formula for put that I will be giving it later. So now let us calculate d1. Okay. So d1 equals ln S naught by E plus R plus 0.5 sigma square into T divided by sigma root T. Okay, so this is the formula for d1, and so let us apply the values in the formula. That would be d1 equals ln S naught is the current price, that is 486, ln is the normal lot, divided by strike price, which is 500, plus R is the interest rate, which is given as 0.09, plus 0.5 into sigma square. Sigma is standard deviation, which is given as 0.54 square, multiplied by time. So time is given as 65 days. So remember, always these days should be converted into month. So 65 by 365. You will be getting the value as 0.06. Okay, so we have got the value of d1 as 0.06, and for calculation of d2 we have a formula, simpler one, that is d1 minus sigma of root t. So this will be .06 minus 0.54 into root of 65 by 365. So you will be getting a value minus 0.17, minus 0.117. Okay, so we have got the values for d1 and d2, and let us see how we can calculate, how we can find out n of d1, normal value of d1. For that we should be using the tables, normal distribution tables need to be used. So we have calculated d1 to be 0.06 D2 to be minus 0.17, and in the formula this is the normal value of the normal distribution value of the D1. Okay, so we have to use normal distribution tables, and we have already done in the class. Anyhow, let me so I am using the table area under normal curve. Okay, for 0.06 we need to find out the table value. For D1 value 0.06 we need to find out the table value. If you look in the table, for 0.06 it will be given as 0.0239. Table value for 0.06 is 0.0239. Okay. See, as a thumb rule, if you have positive value for D1, you add 0.5 to the value you get from the table. Okay, that it is based on the normal distribution graph, where we have graph like this, and this value pertains to this area, so we need to take this full area. Okay, so we are adding 0.5. So n of D1 will be 0.5 plus 0.0239. This will be 0.5239. So we have calculated the value for D1. Okay. Then find out the table value for D2. D2 is minus 0.17. For this, you find out the value for 0.17. Okay. Then I will tell you how to do it. So 0.17, the value is 0.0675. 0.0675 is the value for 0.17. But we are concerned with minus 0.17. Hence, as it is in the minus symbol, n of T2 will be 0.5 minus 0.0675. Okay. See, here it pertains to this area. So we have to deduct this particular area. So we are getting it as 0.5 minus 0.0675. This will be 0.4325. 0.4325. So we have calculated, we have found out what is D1 and what is D2. Okay. Now we can apply in the formula to get the option value. So call option value will be S naught. Okay. So S naught is 486 current market price multiplied by n of D1, the value we found out to be 0.5239, 0.5239 minus exercise price is E is 500, exercise price E is 500, okay, into e power minus RT, that will be minus R is given as 9%, so 0.09 multiplied by T is 65 by 365 of D2. N of D2 value we have found it to be 0.4325. 0.4325. Okay. So when you solve this, you will be getting an answer of 41.8. 41.8. Okay. So we have calculated the calculation option call option value to be 41.8. Okay. Similarly, we can do put option value calculation, and let me write the formula for put option value. Okay. The put option value formula is given as E into e power minus RT into NR minus D2. You need to remember these formulas. Minus S0 into NR minus D1. It is almost reverse of the call option formula. Okay. And we need to find out minus D1, N of minus D1 and N of minus D2. Okay, N of minus D1 and N of minus D2. We have already calculated D1 and D2. N of D1 is N of 0.06. So N of minus D1 equals N of minus 0.06 is D1 value. We have to add minus 0.06. Okay, and here the D2 value is already minus 0.17. N of minus into minus 0.17. So what will happen is this will become N of minus 0.06. Here N of plus 0.17. As both minuses will get cancelled, you will get plus 0.17. Now again you find out the value for table value. For 0.06, we know table value is for 0.06 is 0.0239. 0.0239. Table value for 0.17 is 0.0675. 0.0675 for 0.17. Okay. As there is a minus symbol, as I told you. Okay. So N of minus D1 would be, we have to deduct 0.5 minus this value. Okay. 0.5 minus 0.0239, and here as it is a plus value we have to add to 0.5. N of minus D2 will be 0.5 plus 0.07. Okay. So as there is a minus symbol, we need to deduct that value from 0.5. As when there is a plus symbol, you have to add 0.5 to that. Okay. So in this case, N of minus D1 would be, so we have already done the calculation. So N of minus D1 will be 0.4761, 0.4761. N of minus D2 will be 0.5675. 0.0675. Here it is 0.0675. Okay, I've done a small mistake. It is 0.0675. So n of minus 2 will be, n of minus d2 will be 0.5 plus 0.0675, it will be 0.5675. 0.5675. Okay. So the formula is given. We have calculated n of minus d1 and n of minus d2. Let it be here. Let us add the, let us apply the formula to get the put option value. So put option value will be E, exercise price is 500 multiplied by e power minus RT, that is 0.09 into 65 by 365 minus S naught is 486 into n of minus d1 is 0.4761. 0.4761. If you solve this, if you find out the solution, you will be getting a value of 47.85. 47.85. So we have calculated call option value and put option value. The most important thing is calculation of the normal distribution value, which is a difficult part. So that there also you find out the table value. If the d1 is plus, you add 0.5 to the value. If the d1 is minus, you deduct the value from 0.5. You will get that value. When you are calculating for n of minus d1, then minus of the already having d1 value. So be careful when you are doing the calculation. So this is actually, when you are, if you could follow this, it is easy to understand. Okay, thank you.